This is number 17 on page 75, another absolute value inequality. I already have the absolute value of this expression is isolated on one side, so I'm going to take that expression and set it equal to 1/2 to find the critical point, and set it equal to negative 1/2. And so again, with this, I'm finding the critical points. Okay, so I will clear the fraction here. The lowest common denominator, 4 and 2, is 4. So I'll get t minus 2 equals 2. So t is equal to 4. That's one critical point. And I'll do the same thing over here. I'll clear the fraction. So I will have t minus 2 is equal to 4 divided by 2 is 2 times negative 1, negative 2. So t is equal to, when I add 2 to both sides, I get a 0. So t equals 4 and t equals 0 are the critical points. So I will graph those. Here's a 0, here's a 4, and they're going to be, because this is a less than or equal to, these will both be solid. So I'm looking at the interval in here, to the left, and to the right, 3 intervals, and the solution range will be either out on these two or it'll be in here. So 0 isn't easy to test because we know it's a solution, it's one of the critical points. So I'm looking up at the original, and I see that if I can use 2 to test 2 inside of here, if I test that value for t, that'll work out nicely. I'll subtract 2 and get a 0 here. So if I look at the original inequality and I substitute a 2 for t, I get a 0, right? 2 minus 2 is 0, divided by 4 is 0. And the absolute value of 0 is in fact 0, and in fact less than 1/2, so less than or equal to 1/2. So that means my solution is inside this interval, and I will leave it to you to test any value to the left of 0. You can try a huge negative value, or any value to the right of 4, and it should not make the original inequality true. So going back and evaluating my solution, I've got a 0 as my left endpoint, a 4 here, and this is going to be less than or equal to t, which is less than or equal to 4. And that's it.